December 1941. A telegram lands on a desk inside the War Department. The paper is thin. The words on it are not. American factories are dying, not from bombs, from friction. Cutting tools are going dull halfway through a single shift. Lathes that should be shaping artillery barrels are grinding themselves into scrap. Shell casings, millions of them desperately needed, are trickling off production lines at a pace that wouldn't arm a single division. The greatest industrial machine ever built by human hands is seizing up like an engine without oil. And the oil, in this case, has a name. Tungsten carbide. Most people hear that term and think of bullets, armor-piercing rounds, the sharp end of the stick. But that's only the surface. Tungsten carbide is the thing that makes the thing. It's the tooth on the cutting tool that shapes the steel. It's the edge that carves the rifling inside a cannon barrel. It's the jaw that stamps a cartridge case into form. Without tungsten carbide, you don't just lose ammunition. You lose the ability to manufacture anything at all. No tanks, no ships, no aircraft engine blocks, nothing. The entire arsenal of democracy doesn't stall at the battlefield. It stalls at the factory floor. And America, in the winter of 1941, has almost none of it. The numbers are brutal. Over 90% of the world's tungsten supply sits in mines controlled by foreign powers. China, Portugal, Bolivia, nations whose loyalties are fluid and whose shipping lanes are now hunting grounds for German U-boats. Every ounce that reaches American soil does so at the mercy of a torpedo. The War Department knows this, the generals know this, and somewhere in a boardroom far from the front lines, someone else knows it too. Because the shortage wasn't an act of God, it was an act of business. 1928, a decade before the first Panzer rolled into Poland, two corporations sat across from each other in a room and carved up the world. On one side of the table, General Electric, America's titan of industry. On the other, Friedrich Krupp AG, Germany's oldest and most powerful arms manufacturer. The same firm that would soon forge the cannons, the tank armor, and the submarine hulls of Adolf Hitler's war machine. These two shook hands, and what they agreed to would cripple American industry for the next 14 years. The deal was elegant in its cruelty. Through its subsidiary Carbide, General Electric secured exclusive control of tungsten carbide production and distribution across the Western Hemisphere. Krupp held Europe and Asia. They fixed prices, they divided markets, and they systematically destroyed any competitor who dared manufacture cemented carbide outside their cartel. The numbers tell the story in a single breath. Before the agreement, tungsten carbide sold for $48 a pound. After, $453, a 900% increase. Overnight, the material that every machine shop in America needed to cut hardened steel became a luxury. Small manufacturers couldn't afford it. The U.S. machine tool industry, the backbone of any wartime mobilization, was strangled in its crib a full decade before Pearl Harbor. But price fixing was only the surface crime. Beneath it was something far darker. As late as 1940, with Europe already burning, General Electric was still honoring the terms of its pact with Krupp. Carbide representatives were meeting with Nazi intermediaries in Zurich, neutral ground, and handing over detailed reports on exactly how much tungsten carbide America was consuming. These weren't courtesy updates. They were royalty calculations. Every pound of carbide sold in the United States generated a payment that flowed directly into the accounts of a company building weapons for the Third Reich. American dollars funding German artillery shells. While American boys were being drafted. It took a Senate investigation to drag this into the light. The Truman Committee, formerly the Senate Special Committee investigating the National Defense Program, tore through the records of international cartels in chemicals, electrical equipment, and strategic metals. And when they reached tungsten carbide, they found their most damning evidence. The GE Krupp arrangement wasn't buried in some footnote. It was Exhibit A, proof that an American corporation had actively throttled Allied production capacity in exchange for monopoly profits. The Justice Department moved. Twice. Indictments came down against General Electric and Carbide in 1940 and again in 1942. Criminal conspiracy, restraint of trade, collusion with a foreign enemy. But indictments don't win wars. Factories do. And someone still needed to solve the tungsten problem. So if GE created the crisis, who actually fixed it? Latrobe, Pennsylvania, a town of church steeples and rolling mills tucked into the Appalachian foothills about 40 miles east of Pittsburgh. Population, barely 11,000. Not the kind of place you'd expect to find the man who saved American manufacturing. But that's the paradox. The company whose name is in every history book, General Electric, was the one bleeding the country dry. And the man who actually solved the problem worked out of a shop so small you could miss it from the road. His name was Philip M. McKenna, independent metallurgist, self-taught in the brutal, empirical tradition of men who learn by burning their hands. McKenna had been experimenting with cemented carbide since the early 1930s, and from the start, he refused to play by Carbide's rules. GE offered him a place inside the cartel. He said no. They threatened him with patent lawsuits. He fought back. They tried to choke his supply lines and price him out of the market. He kept going. Philip McKenna was not a man who folded. And it's a good thing he didn't, because General Electric's prized product had a fatal flaw. Standard tungsten carbide, GE's bread and butter, worked fine for cutting cast iron. Slow, brittle, predictable cast iron. But the war didn't need cast iron. The war needed steel. High-tensile, armor-grade steel. And when you put a GE carbide tool against hardened steel at any serious speed, something catastrophic happened. The steel chips didn't fly away clean. They welded themselves to the tool tip. They fused. They built up in a molten ridge that gouged a crater directly into the cutting face. Machinists had a word for it: cratering. And cratering killed tools in minutes. GE's carbide, for the one application that mattered most in wartime, high-speed steel cutting, was functionally useless. McKenna saw the problem differently than anyone at General Electric. He understood that pure tungsten carbide was chemically hungry for steel. At high temperatures, the carbon in the carbide bonded with the iron in the steel, and that bond destroyed the tool from the inside out. The fix wasn't to make the carbide harder. It was to make it chemically inert, indifferent to steel. And the element that gave him that indifference was titanium. In 1938, McKenna patented a tungsten-titanium carbide composite. He called it Kennametal. It was a name the entire American defense industry would come to know by heart. Kennametal didn't crater. The titanium created a thermal barrier at the tool's cutting edge, a molecular shield that refused to bond with the steel chips screaming across its surface at temperatures exceeding 1,000 degrees. The result wasn't incremental. It was a revolution measured in surface feet per minute. High-speed steel, the old standard, could cut at 50 to 100 surface feet per minute before the tool gave out. GE's tungsten carbide pushed that to 200, maybe 500 on a good day, but only on cast iron. Try it on steel, and the tool was garbage within minutes. McKenna's Kennametal cut steel, hardened, wartime grade steel, at 500 to 1,000 surface feet per minute. And it lasted 20 times longer than high-speed steel, 50 times in some applications. A single Kennametal insert could outlast an entire box of conventional tools. The market responded the way markets do when something actually works. McKenna's sales went from $30,000 in 1939 to $7.5 million by 1943. A 250-fold increase in 4 years. The Ordnance Department didn't just notice, they intervened. Military procurement officers realized that McKenna's carbide was the only material on American soil capable of sustaining the high-speed production of shell casings and armor plate. Without Kennametal, the production quotas were fantasy. And so the government did what it should have done a decade earlier. It broke GE's monopoly. Not gently, not diplomatically. It forced the market open, compelled licensing, unsealed patents, and cleared the path for independents like McKenna and Firth Sterling to manufacture at scale. The real invention wasn't a single alloy. It was the liberation of an entire suppressed industry. Dozens of companies flooded into a space that had been locked behind a cartel wall for 14 years. McKenna's carbide didn't just fill machine shops. It fed directly into the Ordnance Department's most ambitious weapons program, high-velocity, armor-piercing ammunition. His titanium tungsten composites became the outer cores of shell designs engineered to do one specific thing: punch through German armor plate at range. And that shell had a name. The round that changed the math was designated M93, hypervelocity, armor-piercing tracer. And every ounce of it was engineered around a single idea: that speed kills armor better than weight ever could. Start with the core. A cylinder of tungsten carbide machined to tolerances measured in thousandths of an inch. Dense, brutal, about 3 pounds and 15 ounces, roughly the weight of a half-gallon of milk. That core sat nested inside a body made not of steel, but of aluminum. Light, almost disposable. Behind it, a steel base plug sealed the propellant gases. Around its midsection, a rotating band of gilding metal, copper alloyed with zinc, gripped the rifling grooves of a 76mm gun barrel and set the entire assembly spinning at thousands of revolutions per second as it left the muzzle. The genius was in the trade-off. A standard M62 armor-piercing round weighed 15 pounds and left the barrel at roughly 2,600 feet per second. Respectable. Dangerous. But not enough. Not against a Panzer's glacis plate. Not against rolled, homogeneous armor 80 millimeters thick, sloped at 55 degrees. The M62 would gouge, crack, and bounce. The M93 weighed 9.4 pounds, lighter by more than a third. And the energy that would have gone into pushing all that extra steel went instead into raw velocity. 3,400 feet per second. 800 feet per second faster. That might sound like a modest bump until you remember how kinetic energy works. Kinetic energy equals 1/2 mass times velocity squared. Squared. Double the speed, you quadruple the impact. The M93 didn't just move faster, it hit exponentially harder. And upon impact, the aluminum carrier shattered and peeled away like a cocoon, concentrating every joule of that monstrous energy into the narrow tungsten carbide penetrator. A freight train's worth of force driven through the tip of a pencil. At 500 yards, the M62 could punch through roughly 116 millimeters of armor. The M93, at the same distance, drove through 157. 41 millimeters of additional penetration. That margin was the difference between a deflection and a kill. But this was not a magic bullet. Carbide is hard, and hardness comes with brittleness. Against highly sloped armor at extreme range, the core could shatter on contact or skip off the plate like a stone across water. The M93 demanded discipline. It demanded the right angle, the right distance, the right moment. It was a precision instrument, not a sledgehammer. And the Army treated it that way. When the M93 was standardized in July of 1944, it was not handed out to every Sherman crew in France. It was allocated, carefully, deliberately, to tank destroyer battalions, the specialists, the units whose entire doctrine was built around one mission: find a Panzer and kill it. This wasn't just about scarcity, although the carbide cores were scarce. It was a doctrinal choice. You give your best scalpel to your best surgeon. The 704th Tank Destroyer Battalion was one of those surgeons. And in September of 1944, they walked into the operating room. Lorraine, France, the grain fields east of Arracourt. Fog so thick you couldn't see past the hood of your own vehicle. And somewhere inside that fog, 260 German tanks were rolling south to cut Patton's Third Army in half. This was Hitler's counterpunch. The 5th Panzer Army, spearheaded by the 111th and 113th Panzer Brigades, equipped with factory-fresh Panthers straight from the production line. 75mm high-velocity guns, 80mm of sloped frontal armor. On paper, these machines outclassed anything the Americans had in the field. The Panther was faster than a Tiger, better armored than a Sherman, and carried a gun that could kill at over a mile. This was supposed to be a slaughter. It was, just not the one the Germans planned. The 4th Armored Division held the line with M4 Shermans, outgunned, under-armored, and fully aware of it. But threading between them low and fast were the M18 Hellcats of the 704th. 18 tons, open-topped turrets, armor so thin a heavy machine gun could punch through at close range. On paper, the Hellcat was a death trap. In practice, it was the fastest armored vehicle on the Western Front. 50 miles per hour on a road, and its 76mm gun was loaded with M93. Captain Tom Grendler's platoon strikes first in the fog, then Lieutenant Edwin Grendler, then Captain J.F. Carpenter. Carpenter pushes his Hellcats through zero visibility, using the M18's speed to swing wide and catch the advancing Panthers from the flank. His gunners can barely see. They fire at engine noise and silhouettes. 76mm guns bark through the mist. Carbide cores cross the gap in less than a heartbeat. Panthers lurch, smoke, and stop. 6 enemy tanks destroyed under Carpenter's command, including 2 Tigers. Not by a bigger tank, not by air support, by speed, fog, and a 4-pound carbide spike launched at 3,400 feet per second. Over 4 days, September 19th through the 22nd, the 4th Armored Division and its tank destroyer attachments shattered the German counteroffensive. The Americans lost 48 tanks. The Germans lost over 200 destroyed or damaged. After-action reports used language that career Army officers almost never use. They called the 76mm gun with HVAP ammunition superlative. The Panther, the pride of German armored engineering, was beaten not by a superior tank, but by a superior bullet inside an inferior one, fired by crews who understood that doctrine and metallurgy could overcome raw armor. The fog cleared. The fields outside Arracourt were burning. Panthers sat gutted and still, their turrets cracked open like skulls. And somewhere in that wreckage, buried inside fractured armor plate, sat the shattered remains of tungsten carbide cores forged in a Pennsylvania workshop 3,000 miles from the war. The war ended. The carbide didn't. January 1947, a federal courtroom in New York. Judge John C. Knox reads the verdict. Guilty. General Electric, Carbide, International General Electric, all guilty of criminal conspiracy. They had, in the court's own language, unlawfully monopolized the tungsten carbide market in the United States through systematic price fixing, organized boycotts of independent manufacturers, and sustained collusion with Friedrich Krupp AG, the primary arms manufacturer of Nazi Germany. For over a decade, they had strangled an industry, inflated prices by 900%, reported sensitive production data to Nazi intermediaries, and funneled royalty payments directly into the war chest of the Third Reich, all while American factories starved for the one material they needed to arm a nation. The penalty? Corporate fines ranging from $10,000 to $20,000 each. Executive fines, including Dr. Zay Jeffries, the GE vice president who personally oversaw the cartel arrangement, $2,500 per person. No prison time, not a single day. A conspiracy that generated millions in monopoly profits, that actively undermined American war readiness, that sent American money to a regime building gas chambers and V-2 rockets, settled for less than the price of a new car. $2,500. That was the cost of treason in 1947. And Philip McKenna? The man from Latrobe who refused the cartel, weathered the lawsuits, cracked the cratering problem, and handed the Ordnance Department the only cutting material capable of sustaining wartime production? No medal, no presidential commendation, no ceremony on the White House lawn. McKenna went back to work. He kept innovating. In the 1950s, his company pioneered the throwaway indexable carbide insert, a small, replaceable cutting tip that eliminated the need to resharpen tools entirely. It was, in its quiet way, as revolutionary as Kennametal itself. It transformed manufacturing worldwide, and almost no one outside the machining industry has ever heard his name. Kennametal became a cornerstone of American industrial power, not because anyone celebrated it, because it worked. Because every machine shop in the country eventually ran on variations of what McKenna built in that small Pennsylvania workshop with tungsten dust under his fingernails. Look around. Every precision-cut engine component in every car on the road, every turbine blade in every jet engine crossing the Atlantic, every surgical implant carved from titanium and seated inside a human hip, every aluminum airframe panel milled to aerospace tolerances, all of it shaped by tungsten carbide tooling. All of it descended in a direct and traceable line from the metallurgy that won the Tungsten War of 1942. The title of this story promised you that GE invented carbide cores that cracked Panzer steel. That's the myth. The truth is darker and more human. A monopoly created the scarcity. A Senate investigation exposed it. A federal government broke it apart, too late, and with penalties too small to matter. An independent metallurgist in a small town solved the actual problem alone against legal and economic pressure that would have crushed most men. And soldiers like Carpenter proved the solution in a fog-covered field in France, firing 4-pound carbide cores into the flanks of Panthers they could barely see. The invention was never a single moment. It was a struggle between corporate greed and national survival, between monopoly and ingenuity, between the men who profited from the shortage and the men who died because of it. GE paid $2,500. McKenna changed the world.